Hello everyone. In this video, we will continue to differentiate or to find derivative of a function, and we will apply the quotient rule. Quotient rule applies if you have a function divided by the other, and they are both in the same as a function of x. They both have the same variables as x. Okay, so you probably asked me this question. You said, okay, why don't I take x minus 3 raised to the exponent 3, and then I bring it up as a numerator, which is x minus 3 to the exponent negative 3, and then you apply the product rule. The argument here is some student told me that then it is more simplified, so I don't need to touch the quotient rule at all. However, I would like to remind everyone that the quotient rules and the product rules, they are invented for a reason. So we should make use of them. And working with the correct rules is, in fact, save us a lot of tedious steps when we have to simplify our answer at the end. So if you want to use the product rule, it's fine. As long as you do it correctly, then the algebra is not that bad. But you just apply the rule that asking you to apply, then I think the simplification at the end is not that difficult. Okay, so in working with the quotient rule, your numerator is always a u and your denominator is always the v. So you cannot be flexible in this case that define whatever as u, whatever as v, as the product rule that we did in previous video. So quotient rule is restricted to u has to be numerator and v is a denominator. Okay, so u is negative 5x minus 2 in this case. So I have du over dx as negative 5. Okay, and then v as x minus 3 all about to exponent 3. So dv over dx is equal to 3 times x minus 3 all of it raised to exponent 2, and I time that with 1, which is the chain rule. The derivative of x is just equal to 1. Okay, so let me correct this x to make sure that I write the x. So this is the chain rule. And you don't need to write this number 1, but I just want to write it so everyone, just to remind everyone that we apply the chain rule we don't have to write a 1. Okay, so what about v squared? So then we have x minus 3, all of it squared. Okay, I mean to the exponent 3, and then you raise everything to the exponent 2. So working with this, you remember the formula that we did earlier. The formula said that we are raising a power to an exponent. So then what you need to do is you need to multiply these two exponents. So you take 2 times 3, so which is 6. So I will write that down. X minus 3, all of it to the exponent 6. Okay, so now that we have everything that we needed, we are going to substitute into the formulas. So dy over dx, again, make sure that we write dy over dx because you are telling the reader that you are going to differentiate now and apply the quotient rule. So quotient rule always start off with v, then time du over dx, and subtract u times dv over dx, the whole thing divided by v squared. So v is x minus 3, all of it to the exponent 3, times negative 5. Okay, subtract u, which is negative 5x minus 2, and then I multiply by derivative of v as a function of x, so I can write 3, and then I can write x minus 3, all of it square, and this whole thing here divided by x minus 3 to the exponent 6. Okay, so the next step is to pull out the common factor as a numerator here. So with the numerator, we have to factor them, or we simplify by factor out the common factors. So as I mentioned earlier in previous video, in the video with the product rules, I'm asking everyone to take a look at the same common factors, and the common factor can be a binomial as well. So between x minus 3 raised to exponent 3 and x minus 3 raised to exponent 2, the lower exponent would be the 2. So this will be my common factor. So x minus 3 to the exponent 2 will be my common factor. So that means I will have x to the exponent 3 to exponent 1 left in this term. For this term, I just have x to minus 3 to the exponent 1 left. And for the second part, I just have 3 times negative 5x minus 2 left, and this one has already gone out to be a common factor. Okay, so this whole thing here is divided by x minus 3 to the exponent 6. Okay, so it's pretty simple now in terms of simplification. So you see that this whole thing and that whole thing here is you divide 2 power with the same exponent. You can subtract the exponent, or you can simplify the term to this. So that simplify this to a exponent 4. Okay, so then I will have dy over dx equal to the exponent 4. Okay, now I'm going to distribute what I have inside this bracket, distribute, and then simplify by collect like term. So I should have minus 5x plus 15 and plus 15x, and then add the 6. Okay, so then I should have it as 10x plus 21. Everything divided by x minus 3 raised to the exponent 4. Okay, as the final answer. Alright, so that's the quotient rule. And if you want to check it out, you can go ahead and raise this to the exponent negative 3. So you write it as negative 5x minus 2, all of it multiplied by x minus 3 raised to exponent minus 3. And then you can also apply the product rule and then try to simplify to this final answer at the end. Okay. However, I don't recommend that. If the function is given to you in this form and asks you to use quotient rule, then using quotient rule, it looks tedious and a lot of detail in these formulas, but at the end, when you simplify your final answer, it's a lot simpler. All right. I would like to ask everyone to take a look at the end of this handout. I do have quite a few exercises for everyone to work on. Okay, ranging from like you raise a function to a power, and to working with individual functions. So a lot of rules apply here, and I really want everyone to figure out what rule that you need to use in most of this question. And I would like to go over question number 12. Okay, so I also want to apply the quotient rule in this case. And this question asks me that given the function y equal to x squared minus 2 divided by the square root of x squared minus 1, and I want to evaluate y prime of 2. So y prime means you have to find derivative, and then the 2 means that after you found the derivative, you substitute the value of 2 as x equal to 2 into this y prime equation, then you can give a value. So in this case, basically, you are finding the slope of the line tangent to this function at the point x equal to 2. Okay, so let me write it down on my blank page up here. So I already complete my question number 9. I don't need to continue with question number 9. Okay, so I just want to remind everyone that this is number 12 on practice for derivative rules. Okay, so question number 12 asks me to write that given function y equal to x squared minus 2, everything divided by the square root of x squared minus 1, evaluate y prime of 2. So that means this question, they can ask you like this too. Determine the slope of the line tangent to function y at x equal to 2. So that the question can be asked like that as well, because basically when you find derivative of a function, that means you find the slope, and if you have the value for x, then you can find the actual numerical value for that slope. Alright, so I'm going to apply quotient rule in this case. Okay, so I'm not going to bypass and try the product rule, because I just want to make sure that we master the quotient rule. So u will be equal to x squared minus 2. Okay, so du over dx will be equal to 2x. Excuse me. So v is x squared minus 1, all of it raised to the exponent a half. Okay, so in this case, you identify v as also your numerator. So this numerator is x squared minus 1, all of it raised to the exponent half. Okay, so then dv over dx is a half x squared minus 1. You take 1 away from half, so it will be negative half, and then multiply by 2x. Okay, so at this point, I can see that this 2 can cancel with that 2, and my dv over dx now will become x times x squared minus 1 to the negative half. So what about v squared? Okay, so v squared is x squared minus 1, all of it raised to the exponent a half, and you raise all of this thing here to the exponent 2 because you square your entire function. Then the reminder that you take this multiply by that, so a half times 2 is just 1. So in the end, you should have x squared minus 1 as v squared. Alright, okay. So let's substitute into our equation. So the equation said that, so quotient rule say derivative of u divided by v, everything as a function of x. So what you need to have is you take v times your du over dx, you subtract u times dv over dx, and the whole thing divided by v squared. So I'm going to put in what I have. So v is so I better write dy over dx. I did ask everyone to make sure that you indicate the notation. V should be x squared minus 1, all of it to the exponent a half. Okay, so du over dx, which is 2x, and I subtract that with u, which is x squared minus 2, and time by derivative of v as a function of x, so x times x minus 1, all of it raised to the exponent negative half. Okay, the whole thing divided by x squared minus 1. Okay, so let's double check. This is our v. This is du over dx. This is u. And this is dv over dx. And this is my v squared. Okay, so we'll take a moment to make sure that we've done this correct. So v, and then du over dx, and then u, and then dv over dx, and then v squared. Okay, so now when we simplify, again, go back to the process of taking common factors. You are having this here as your common factors, right? So x squared minus 1 to the exponent a half, and x squared minus 1 to the exponent negative half, is actually there's common factor between these two. So you will pull out the one with the negative exponent, because negative half is smaller than half. Okay, so I should have x squared minus 1 raised to the exponent negative half. Then 2x and x, I should have x as a common factor. Okay, so then what I have next is, inside this, since I pull out the half and divided by, so I should have x squared minus 1. This one just raised to the exponent 1. And here's 2 left. And for this part here, I should have x minus 2 left. X squared minus 2 left. And the x has already come out here as my common factor. So I don't have any more x left. And the x minus 1 to the negative half has already been out here as the common factor. Okay, so this whole thing is divided by x squared minus 1. Okay, so then dy over dx is equal to x times x minus 1 to the negative half. And inside the bracket, I should have this like 2x squared minus 2 minus x squared plus 2. And here is my x squared minus 1. Okay, so let me rewrite this. Negative half. So at this point, what you can do is, I would like to show everyone the process of how to simplify. Okay, so this and that. You can bring this one down to the bottom here, and then make that into the positive half. So positive half plus the 1, because basically this is x squared minus 1 to the exponent 1, and you bring it down to the denominator. You should have it at x minus 1 to the positive half, and 1 plus a half should give you 3 over 2. Okay, so it's just like a reminder to everyone on the side to know why I will be writing this as x squared minus 1, all of it to the exponent 3 over 2. And on top, I still have x left. Inside the bracket, this and this combined, I should have x squared, and that cancel out. So in the end, x squared times x, I just have x to the exponent 3. Okay, so x to the exponent 3. So now I am going to evaluate y prime of 2. So I can write dy over dx, evaluate x equal to 2. And this is the same as I am writing y prime of 2. So let's see what we have. So now you are going to substitute in 2 to the exponent 3. And then you have 2 squared, subtract 1, all of it to the exponent 3 over 2. All right, okay. So what I have, the top will be 8. And 2 squared is 4. 4 minus 1 will be 3. Okay, so I have 3 raised to exponent 3 over 2 as the value. So if you want it to look good, so what you have is, I will be writing it as a over 3 square root of 3 as one of the answer, because 3 raised to exponent 3 over 2 will be, okay, so a lot of algebra that I need to remind everyone in this case. So this will be 3 times 3 to the exponent half. Everyone agree? Because this, in fact, 3 raised to smaller than 1. 1 plus a half will give you 3 over 2. So from here, I write this 3. From there, I write it as the square root of 3. And what I will do next is I will rationalize the denominators. So I will have a times root 3, the whole thing divided by 9. Okay, rationalize the denominator means that I need to multiply the denominator by root 3. Okay, so here I time by root 3 as well, because root 3 times root 3 will give me 3, and then 3 times 3 will give me 9. So therefore I have that as the final answer. Okay, as rationalize the denominators. So your answer can be like this, or you can express your answer like this, but the best is you must express your answer as rationalize the denominators, because we don't want any radical as the denominators. Okay, so it's just a few reminder here, the review of algebra.